Thank you, sir. Over to you.
So, good afternoon all. So, this is technical session 7A, Logistics, CSR initiative and total quality management. And I request Chairman Saxena Sahab to please proceed with the session.
Welcome all the delegates. Today's this technical session is about logistics, CSR initiatives, and total quality management. So, Mr. Prakash is with me as a co-chairman, and we will start with some notes. All the papers will be delivered within 10 minutes of time, and after 8 minutes, we will give a whistle, just an alarm, so that timely completion can be done accordingly. Can we start?
Yes, please.
Good afternoon. Myself, Prakash. Just one announcement before the starting of this session, that there is one paper to be delivered by our DG sir. That is the implementation of the total quality management in NCBM. Fortunately and unfortunately too, there is a AGM going on there in this premises itself. So he is engaged there. So we requested the organizing committee here that please keep a separate session for Dr. Mahapatra for this special topic, that is the total quality management, that will start just after conclusion of this session. So please be with us after this session. Immediately after this session, Dr. Mahapatra will deliver his speech on the total quality management. Thank you. Please, sir.
So, Chairman Sahab, I think you will have to start from second.
Okay. So the first paper will be presented as impact of CSR initiative on water footprint of cement plant. And this will be from V. Ramaraju Dalmia Cement, Bharat Limited, India.
Good afternoon, sir. Good afternoon, one and all. This is Ramaraju from Dalmia Cement. So I based out Kadapa plant of Andhra Pradesh. So there we have 2.5 MMT integrated cement manufacturing plant. So I am here to present about impact of water conservation project implemented through our CSR initiative. So it is basically out of fence. I mean, we implemented this water and soil conservation project across our cement plants surrounding villages. So I'm going to present what was the scenario before the CSR initiative, and post the project, what is the impact and what is the outcome we witness. Presentation, please.
Please display the presentation.
It's not opening. Is it?
Presentation is not, they are not Hello.
Hello. Sir, there is some technical issue with this presentation opening. So we are looking into that.
Can we
Yes, yes, I think.
for the next paper?
I think.
Sorry, Mr. Ramaraju, there's a technical difficulty. So we will take this paper in the last. So the next paper is reducing carbon footprint in cement industry, energy saving by compressed air leak elimination. It will be presented by Ms. Asha Kumari and Jigar Shah, Henkel Adhesive Technologies India Limited.
A very good afternoon to all, and thank you to the dignitaries for providing me with the opportunity to present this paper in front of you. I am Asha, and today I am going to speak about energy saving by compressed air leak elimination. So we are aware that India is the second largest cement producer in the world in the terms of production capacity. So when we speak about being the second largest in the world, so we can very easily assume that how much of power goes into this production. And when there is so much of power consumption in an industry, so there would be sources from where we can prevent this consumption or the leakages, where we have opportunities to prevent and save energy. So due to the unwanted air leaks, around 20% of the acquired compressed air, which is generated in a power plant, actually reaches to the production capacity. And we all are aware that almost 40% of the cost of production is contributed towards the energy production. So if we start saving any of the leaks, or we start preventing any of the leakages, which leads to the wastage of energy, we can move towards a more green nation and contribute to the overall zero net carbon emissions goals. Now, compressed air leaks carry a significant high cost saving and are a very great opportunity in saving the energy in compressed air systems. Compressed air systems are an integral part of any cement plant, and they are used at various process locations for moving the raw materials from one place to another. Now, keeping into the consideration that how much of compressed air is being utilized in a cement industry, we can easily gauge from the map that only 60% of the produced compressed air reaches the point of production, and almost 30% goes waste in the leaks. If correct measures are taken to identify these leaks and arrest these leaks, we can have a more we can have an optimized system which would be more energy efficient. So how to eliminate this big question or eliminate this cost of air leak, which is costing any cement industry, any and every cement industry? So the factors which go into the equation includes the electricity per kilowatt hour, the number of compressors in the facility, the cumulative output they are producing, and the cumulative compressor horsepower and the air pressure. So these are some of the factors which go into the calculation of how much cubic feet meter of the compressed air is being lost every year and how much it is costing to a cement facility. This is just an illustration of how much a 3 mm orifice at 7 bar pressure can lead to a cost of around 1.5 lakhs per year to a facility. Now, as can be seen, though overlooked, compressed air is one of the biggest contributors to the energy wastage in any industrial facility. If we keep an eye on the compressed air leakages and a solution for all these old piping, the leakage can be arrested and we can increase the overall energy efficient management system. Now, what is the solution? When we talk about the solutions, so there are air leaks everywhere. The most widely used approach to detect these air leaks is a ultrasound leak detector. Why an ultrasound leak detector? So ultrasound leak detector is a method which you can apply in a running plant, and you can find leakages, even the smaller one, not only the ones which can be easily heard in a plant, but there are some very minute leakages which get lost in the surroundings of a power plant or a cement plant. So ultrasound leak detection is the most fastest detection and prevention of air leakage criteria. Now, compressed air energy audits are not so common in any of the cement plants, and if they are taken as a part of annual maintenance, it would not be a disruptive process in the running plant and would lead to a huge cost saving in the complete process. And it's a great opportunity for energy saving and process improvement. So what is zero leak program? So Henkel aims at giving a zero leak and cost saving based on eliminating the air leaks in any cement plant. The leak program consists of 4 stages mainly. The first starting from the detection of the air leaks in the different regions of the cement plant. Then calculation based on the leak points and the compressed air being lost at every point. A detailed calculation is prepared and shared, which actually gives you the losses which the plant has been incurring with respect to the compressed air being lost in various processes. Then based on the leakage sizes and the different medias where the leak has been detected, Loctite solution is suggested based upon the different application or the different areas of application. And the last, to close the loop, the personnel in the plant are trained to use those solutions so that in future they are ready to cater to any such leakages. So overall, the leak program is a completely proactive maintenance program where you are proactively arresting all the leaks by identifying the leak points which can cost you money in the later processes. So the arresting leak process starts from an ultrasonic leak detector finding all the air and gas leaks, and based upon the leak's location and its severity, a tag is designated at all the leak points. A leak survey and a summary report is being generated based on identified leak points, and it gives us an estimate of losses and the lost costs of the leak. Taking into consideration, as I discussed previously, the various types of medias flowing and the different type of threads for different pipings, a wide range of thread sealants are recommended, and to ensure that the best products are being used, there is a easy guide which gives you an idea which product should be used. So a product selector guide is available which can be very easily used to summarize that which solution would go at what point. So the paper basically talks about one of the surveys conducted at one of the prominent cement plants, and it has been done for the 2 units. So around 699 leak points were detected at the 2 units of different sizes, different orifice sizes ranging from 0.1 to 0.7 mm at a air pressure of 72.54. You can see, so in 2 units we have identified 69 leak points, and what cost it is causing to the particular cement plant can be calculated based upon the air leak lost from each point of leakage. So the results were documented and it was identified that there was a loss of around 22 lakhs with a price rate of rupees 8 kilowatt hour. So the calculations has been made with respect to rupees 8, and the total loss was at a tune of 22. Now to save these 22 lakhs, there are various range of adhesives which were suggested to arrest those leakage points, and based on that, a calculation of, we could see that around 288 megawatt hours power saving was done, which is finally contributing to a carbon footprint reduction of 227.5 tons, which is itself, this is the impact of doing an air leak survey at one of the units. Just think at the impact it is going to create if it has been added into a proactive maintenance program, and every unit starts following this practice. So I would like to conclude that by eliminating leaks, we are having multiple benefits. The very first benefit is, since we are arresting all the leakages, so the need to add more compressors so that all the processes are efficient is eliminated at the very first hand, which is in turn saving you cost and increasing the productivity at any of the cement plants. It overall improves productivity, and the last benefit, energy efficiency and reduction of CO2, which can be seen from the power savings which have been generated from a particular case. So as we all know that cement industries have been always in the lead of applying all the technologies and getting into the league. So I'm sure all the cement plants leading to a proactive leak arrest program, which not only aims to arrest those leaks, but train the personnel to arrest those leaks in the future, it would be a step towards net zero carbon emission. Thank you so much.
Thank you.
Thank you, Ms. Asha. A nice presentation over this leak protection mechanism and the solution thereof. And thanks again for this presentation to be completed within time. So next presentation is uses of bamboo as alternative fuel to reduce the CO2 emission along with socio-economic development in nearby villages by Amitav Roy, Pallab Kalita and Rohini Beshe from Calcom Cement India Limited.
Good afternoon, honorable dignitaries on the dais and the delegates coming all along from the different parts of India along abroad of the dais. Myself, Amitav Rai, representing Calcom Cement India Limited under the flagship of Dalmia Bharat Cement Limited, located in the northeast Assam, a land of Red River and Blue Hills. We Dalmians are having responsibility not to grow ourselves, but also enhance the shape of the livelihood of the villagers, on the nearby villagers. And accordingly, we have done too many CSR as well as ESR activities, like turmeric production, guava plantation, silk weaving, etc. We have now taken another initiative of bamboo plantation. And accordingly, my presentation is bamboo for reduction of CO2 emission with socio-economic development of nearby villages. We are aware that CO2 emission is the burning issue across the globe. And when over the past century, the average Earth temperature increases by 1 degree centigrade due to greenhouse gases, and mainly was carbon dioxide. And the detail was already discussed by Dr. Ashok Kumar, DDG of Bureau of Energy Efficiency, on the very first day in this special technical session. To produce 1 ton of clinker, 825 to 890 kg of CO2 are emitted. And we, the cement family, working day and night to reduce the CO2 emission by increasing the usage of supplementary cementitious material, solar energy, then blended cement, and by plantation, apart from specific heat consumption and specific power consumption. This slide shows during incineration, co-processing is advantageous by capturing the energy and utilizing the lower leftover ash, which has taken place outside. Cement kiln offers an excellent opportunity for safe and sound recovery of wide variety of alternative fuel to replace fossil fuel. Now the question arises, why bamboo? Now the question arises, why bamboo? In the northeastern state, due to lack of, there is a lack of availability of alternative fuel. And over and above, due to hilly terrain, and we are located in the most remote places, the logistic cost is very high. Then we all know that tree, bamboo, and ocean act as a carbon sink, where carbon CO2 is stored instead of released to the atmosphere. Bamboo absorbs more CO2 from the atmosphere than it releases. It releases 35% more oxygen than with respect to hardwood trees, and hence it is called carbon negative. Bamboo is the fastest growing grass, and due to its rapid growth, it allows frequent harvesting, and in turn, it allows the farmers to have adopt flexible harvesting system, harvesting practices. In the northeastern states, the lot of barren land are taking place due to shifting cultivation, and bamboo can be grown in any type of soil and even in the steep slope. During December 2017, there was an amendment taken place in Indian Forest Act 1927 that bamboo is no longer tree. So there is no legal issue now for cutting of bamboo. Bamboo product plantation and the manufacturing of the bamboo product improve the job opportunities. In turn, the income of the villagers will be increased. As an initiative, we Dalmia Umrangshu unit have taken various steps toward making bamboo projects successful. In the first phase, during October 2021, we had a meeting with the villagers. Then after, we have given training to the villagers with the help of South Asian Bamboo Foundation, the Energy and Resource Institute, etc. Then after, we have undergone a contract with the villagers to buy back bamboo. Then after, during February 22, we have developed a nursery of bamboo, and we distribute fish sapling to the villagers during May 22. Presently, we are exploring to procure a bamboo shredder along with the feeding system, and we have already increased the calciner height up to 47 meters, which is one of the exceptional case in case of Umrangshu, to increase the retention time from 2.8 to 5.2 seconds. Going forward, we will procure bamboo from the villagers and start using through calciner. And we are targeting during April 25, we can start bamboo on a continuous basis. These are some photographs of creating awareness towards cultivation and including field training. This is the photograph of the 6-month mature plant. This is our present bamboo shredding system, which we are receiving wild bamboo from our nearby jungles. These are some data where we identify 145 hectares in 13 villages, wherein 326 families are involved, and total sampling taking place of 72,500. And we are expecting during financial year 24-26, the 2,90,000 of bamboo we can collect, and it will replace 2,300 of coal, as we are estimating as 3,600 of metric ton of bamboo on dry basis. And majorly the family income, per family income will be 44,000 annually, and it will incrementally increase year after year. With this initiative, we have a conclusion that bamboo can be effectively utilized as an alternative fuel in the cement plant, as it has a consistent calorific value and easily available in the northeastern states. Reduction of CO2 emission will take place 2.5 kg of CO2 and per percentage of TSR per metric ton of clinker. As a part of our journey, we consume 1800 metric ton of wild bamboo on a dry basis as an alternative fuel. The reduction of the CO2 emission as well as the socio-economic of the village is the key focus of our unit, and considering the advantage of the weather of the Northeast, it is the most suitable project. This creates the win-win situation for nearby villagers, community, cement industry, and ultimately reduce global warming. Thank you very much. Any question?
We will take the questions in the
Okay,
end
sir.
of the
Okay, sir.
session.
Thank you, sir.
But thank you for doing it before time.
Thank you, Mr. Amitav.
Actually, excuse me, sir. One of our colleagues want to have some announcement. बोला उसको?
So there is some important announcement. One of our delegates' bag has been exchanged with someone else. So kindly check your bags. If anybody finds his bag, then kindly contact help desk. His name is Dr. K. Narayana Rao, Corporate Head, My Home Industries Private Limited. So kindly check your bags. If someone has exchanged by mistake, then kindly contact our help desk. Actually, he has his personal belongings in the bag, so kindly check your bags. Thank you.
So the next paper is Significance of Intermediate Checks of Equipment and Exploration of Various Intermediate Techniques by Mr. P. Shri, V. Nagar Kumar, Bharat Ram, Rishi Raj, and Amit Trivedi from NCCBM.
Thank you, sir. Good afternoon, everyone. Today I'm going to present the significance of intermediate checks on equipment and exploration of various intermediate techniques. These are the contents. This is how the presentation will flow. First, we will understand what is the intermediate checks. This is a very familiar term for all the quality control laboratories, testing or calibration laboratories, especially laboratories which have implemented the laboratory management system as per 17025. The standard mentions the term intermediate checks twice in different clauses. First in 6.4.10, where the intermediate checks are necessary to maintain the confidence in the performance of the equipment. These checks shall be carried out according to a procedure. Then in 7.7.1e, the standard says that mentions intermediate checks on measuring equipment as one of the methods to ensure validity of results. Basically, this is a tool for quality assurance and to ensure that the results generated are validated. Now, one can define intermediate checks that basically they are measurements of an instrument in smaller increments of time than calibration cycle, as per a defined method or a procedure, to ensure that the instrument is still within bounds of the acceptable performance. Basically, for all instruments and equipments, there is a certain fixed interval of calibration. In between that period of calibration, how to ensure that the instrument is working in a reliable and an accurate way. What has there been any major shift or drift in the equipment? To check that, we perform intermediate checks. So their measurement has a smaller time period as compared to calibration cycle. The challenges for many laboratories are that there are no clear guidelines available in intermediate checks. There are a lot of guidelines available for various aspects of implementation of 17025, but there is no as such fixed guidelines for intermediate checks. So in this paper we have through literature survey, through data generated in our own laboratories and available relevant standards, we have pieced together some methods and some ideas to how to carry out intermediate checks. First of all, when an intermediate check needs to be carried out, these are certain scenarios, especially when an equipment or instrument is being transported outside the laboratory purposes, either for the equipment's its own calibration or on the field for testing. Then, of course, as we have seen earlier, that there has to be a schedule in between the two calibration cycles, so that we can ensure that the equipment has not drifted significantly between the two calibration cycles. Then if there are any significant deviations, if we are using an instrument for doing some testing in the laboratory, and if you notice that there are some deviations from the expected results in your routine testing, then as part of the root cause analysis, the first thing we can do is we can carry out an intermediate check on the measuring equipment. And also the instrument's age or the workload, also the calibration data of the instrument. Over the period of time, if we maintain a calibration data, if we make a control chart, also the age and the kind of usage, we can also determine the frequency of interchange accordingly. Also, performance in interlaboratory comparisons or proficiency testing programs is also a tool for deciding the intermediate checks frequency and also the necessary of. There are some certain fundamental differences between intermediate checks for calibration testing laboratories. We have seen that in the initial slide where in two clauses there, it is mentioned by the standard also. One, in 6.4.10 it says when. Basically that is mostly directed to the calibration laboratories. The primary differences is that calibration laboratories generally have highly accurate and stable reference standards, because calibration laboratories perform the calibrations of other laboratories' equipment or instruments. So their reference standards are comparatively more accurate and stable. Second is also most calibration laboratories also have primary reference standard equipment or secondary standard reference equipment, due to which it is very difficult for calibration laboratories to carry out intermediate checks in a conventional manner. For example, a dead weight tester, which is used for the calibration of pressure gauges, which is widely used in the autoclave equipment in cement plants. The dead weight tester itself is a fundamental or a reference standard. So doing an intermediate check for a dead weight tester is a bit difficult. These are the techniques which we have explored and we have listed out. One is repeatability check. We have taken an example for this, weighing balance. This is a very basic method, and it's quite useful for a weighing balance that you can take minimum of 10 readings, calculate the standard deviation. That will be the repeatability error. This, you can put an acceptance criteria either as when you buy the weighing balance, there is a manufacturer specification of repeatability error, or criteria set by the laboratory as per their testing requirements. And this repeatability error should be less than that. Then control charts. Control charts is very useful because they can uncover the inconsistencies and unnatural fluctuations in a process. Also, it gives you an idea of the variability over a period of time. So either the laboratories can set specifications based upon their testing requirements, or simply they can set the control limits as ±2 standard deviation or ±3 standard deviation with respect to the targeted value or the mean value. This is the data generated in NCB laboratories of a muffle furnace over a period of time. We have generated this data and we have plotted the control chart. As we can see, so far the values are lying within the control limits, and that means that furnace is working fine. Then compression testing machine or universal testing machine is again a very crucial equipment in building quality control laboratories. So this is similar to the calibration of CTM or UTM only. Basically, the laboratories should have a calibrated force proving instrument. It could be a proving a load cell or a dynamometer. And a minimum of 5 readings should be taken within the range of 20% to 100%. And we can calculate the accuracy error. Generally, the accuracy error should be 1%. Then using F-test. This is a statistical based test which is used for hypothesis testing. And this method is especially useful for calibration laboratories which have sophisticated equipment. We have applied this method on our own mass comparator, which is basically a high precision weighing balance used for calibration of standard weights. We have in that laboratory and we have used it for applying this test. What we did is we took 5 data sets at 5 kg, repeatability data of at 5 kg over a period of time. Then we calculated the standard deviation for each data set. And then the first 4 readings we have done the pooled standard deviation. and the fifth one is has been designated as standard deviation new. Then the formula for F test is that this is S square nu by S square P, that is a pooled standard deviation, and this gives a value. And there is an F distribution table. Since we generally do the calibration and testing at 95% confidence level, in the table we have taken alpha as 0.05, and when we compare it, the value comes out at 2.12. Now this is greater than the F value of 0.0020. That means there is no significant deviation. So the conclusions are that statistical methods and analysis are the way forward for developing procedures and techniques for intermediate checks. Regular generation of quality measurement data is critical, and this ensures that we have reliable statistical analysis, and also it provides reliable information regarding the equipment's performance, its age, etc. This will enable laboratories to take timely preventive maintenance, fixing calibration schedule, and also planning for replacement. It's very important that the procedure for calibration intermediate checks should be done in a manner which generates reliable data. And laboratories, if they feel or if they don't have sufficient resources, they can also get it done by an external agency, by an external calibration laboratory. And these are our facilities at NCCBM, and we also can help out laboratories for intermediate checks. Thank you.
Thank you, Mr. P. Srikanth.
So the next paper is Case Study, a patented innovation, anti-stick hybrid coating to reduce the downtime of equipment in cement manufacturing plant, by Mr. Jigar Shah, Henkel Adhesive.
Good afternoon all. So as you know that in cement manufacturing plant, there are all solid material handling, and there are always sticking particles challenges are there inside the equipment internal surface. So this particular solution, when we talk about, is a patented innovative hybrid kind of coating that helps our customers and the cement plant operators to overcome from these challenges. Myself, Jigar Shah, I am a senior application engineer from Henkel Adhesives Technologies, and today I am going to present about the benefit of anti-stick coating which we have developed considering the cement plant challenges. So as we can say that reducing downtime with superior anti-stick performance. So in cement plant we can find kind of static and rotating kind of equipment. So here you can see like ID fan impeller and hopper like gypsum hopper, pond hopper, any kind of hoppers are there. Even there are bucket elevators and other things are there. So when we talk about this static and rotating kind of equipments, always the materials, the solid particle materials travels inside the equipment with the help of air velocity, whether there is a high velocity or low velocity. So when material travels inside the equipment, it not only abrades the equipment, but it sticks onto the surface of the equipment. And because when it sticks on the surface of the equipment, some of the equipments like ID fan impeller, it gets imbalanced because of the high vibration. And another equipment like hoppers and all, material get jammed, and there is a clogging of that particular hopper, and it's very difficult to continue the process thereafter. And even it will reduce the overall efficiency of the plant. So altogether, we can say that it will ultimately leads to the downtime, increase the downtime of the plant. Yeah. So when we thought about to develop this particular product, considering the application requirement, so we have visited a couple of plants, cement plants, and we found out that to make a robust product in terms of this particular application requirement, here you can find that we need a product solution like that can provide excellent anti-stick property. At the same time, considering the solid particle abrasion, we need a product having a superior abrasion and wear resistance. Also, the solution has to bond to a different kind of substrate as well, and it is always easy to apply fast curing. So these are all application required. It is really required to make a robust kind of product and solution. So when we look at current solution available in the market like PTFE or HDP kind of plates and coatings, where we can say that they can provide kind of anti-stick property, but when we talk about the abrasion resistance, they will not sustain. And at the same time, there are different kind of ceramic coating is available in the market, where we can say that when we apply that, we can get the abrasion resistance, but we cannot get the anti-stick property, and where we can find the gap here in the solution, and we have started to innovate this particular product. So this particular patented innovative hybrid coating is basically kind of epoxy and silicone-based coating. We have tested this particular product since last, I think, we work around 2 years together with our customer in our lab to develop this kind of product, and finally we observed that epoxy and silicone kind of solution perfects well in this kind of situation. So here you can see that this particular product having very good hydrophobicity, even providing excellent abrasion resistance compared to the ceramic coating as well. So what we did that we have done this particular development of this coating in the two phase. One is the lab test and second one is the field test. So when we talk about the lab test, we have compared this coating with normal ceramic epoxy kind of coating, and where here you can see that the data available with us that when we talk about the abrasion resistance for 5,000 cycles, we can say that only 7 mg of material loss with hybrid kind of coating, and impact is really important in the equipment because material is falling down from the top, and impact testing is very, very important considering the application requirement where that is having higher impact resistance testing as well. Even contact angle and surface energy, you can see the data compared to ceramic epoxy coating is contact angle is very, very high and surface energy is very, very low. Corrosion resistance test, STM B117, we can find very, very low resistance to salt spray test, and even the pull of adhesion test on difficult to bond the substrate like SS316, we have found excellent adhesion to that kind of substrate as well. So these are some of the lab tests that we have conducted in our state-of-the-art NMBL lab in Pune. So let us talk about some of the technology like hydrophilic and hydrophobic, where we can say hydrophilic a kind of terms that can attract the water and other particles, where hydrophobic and super hydrophobic is kind of technology that can repellent the water and other particles. So here you can see that epoxy coating having a 75-degree contact angle and around 39 of surface energy. However, when we talk about the epoxy silicone hybrid, that is having 105-degree contact angle and low surface energy. So as you can see that if we increase the contact angle of the surface and reduce the surface energy, then the anti-stick property we are getting better and better. When we talk about the abrasive resistance, we have used this particular test, we call it Tabor test, and CS70 wheels for 1 kg load continuously, and we can find that it can provide more than 4 times better abrasion resistance than normal ceramic epoxy kind of coating. Another test we have conducted in the lab by taking kind of muddy water, and here we can see that if we can use the ceramic coating, ceramic-based coating, that mud will stick on the surface of the ceramic epoxy coating, but when we dip that particular panel into the muddy panel of anti-stick coating, it will not stick, it will just go away from the surface. Yeah, similar kind of test we have conducted to check the hydrophobicity, flexibility, impact test, and the kind of adhesion test of other material on the surface, and we found that it was fantastic and providing excellent result. So this is all about the lab test. When we talk about the field test, we have conducted some of the trial in cement mill ID fan. Here you can find some of the pictures, and also in the gypsum hopper and gypsum and pond ash bucket elevator. And what we found the result from the customer is that is exceptionally good. Here you can find that when we talk about the ID fan impeller, the cleaning frequency of 2 times per week is there for the without coating or without any kind of coating on the surface. when we talk about the anti-stick coating, after coating application, they will run this particular ID fan without any downtime and sticking issue for more than 3 months. And this is some of the testimonial from our customers and feedback from the customers. Like gypsum hoppers, because of the clogging issue, they need to clean the gypsum, they need to take a shutdown to clean that many times. And after this particular coating application, the hopper runs without downtime for more than 6 months. And again, for the gypsum and pond ash buckets, there is a cleaning frequency of 1 time per week. And there is again a reducing frequency, because when there is a sticking of gypsum or any other particle onto the buckets, there is a delivery quantity is different. So they need to deliver more, they need to rotate more cycle to deliver the same amount of quantity. And again, they are reducing the efficiency up to 50%. So when we apply this kind of coating inside the bucket of gypsum and pond ash, we can see that we can actually increase the efficiency, and there is absolutely no sticking for up to 6 months. So these are some of the fantastic results we have observed in the field. And finally, we can conclude that it is not only help our customers or cement plant operator to increase the efficiency, but also help them to save the cost and save the downtime as well. Yeah. So thank you. I am thankful to our PD team. They are in Pune, and our sales team in the field, that they help us to validate this particular coating in the lab and the field as well. Thank you very much.
Thank you, Mr. Jigar. Thank you.
The next paper is Development of CRM, Targeting Quality Product and Excellence in Competency by Mr. S.K. Shah, V. Nagar, A. Agnihotri, and Amit Trivedi by NCCBM.
So, respected chairman, co-chairman, and delegates from India and abroad, very good afternoon to all. My name is Suresh Shaw, and I am the program in charge of CRM in NCCBM. So, first of all, as you are aware that in the present scenario of globalization of economy, globally accepted measurements are required, where the availability of reference material becomes the crucial for universal acceptance of the product. And recently, Union Minister Shri says India must have its own quality standard for every product and ask industry to align with the world standard. Also, he said that India needs to become a quality conscious nation and adopt quality as an integral part of the process in preparing the downtime of becoming a developed nation by 2047. In line of that, we are developing CRM for quality control and quality assurance for better quality infrastructure in the country. So these are my contents. We will discuss about the global scenario of certified reference material, then our services as certified reference material, then its importance, followed by Bhati Nideshak Dev and case study on development of PSC on chemical parameters. So what is the global scenario of reference material producer? So basically reference material of various commodities such as cements, ores, rocks, semi-processed ores, food, drugs, and many more are being produced by several organizations. And the topmost contributors are NIST, USA, Certified Reference Material, PTB, Germany, NIM, China, European Reference Material, Belgium, Thailand Reference Material, Japan, and many more. And India is majorly dependent on imported CRMs and National Physical Laboratory, CSIR, NPL. The NMI of India is the custodian of national standard, has taken a step forward for the development of CRM, named as BND, in various commodities like cement, water, petroleum, and food. So services of NCCBM in the area of certified reference material. So NCCBM is a premier body in the country as a CRM developer in the area of cement, concrete, building material, and our lab is accredited H17034. And NCCBM started development of CRM since 1990. So far, we have developed many number of CRMs in the area of cement and building materials. And in last 2 years, we have developed 18 number of Bharati Nirdesak Dravya in collaboration with NPL India. And NCCBM CRM are being used in India by almost all cement research divisions, cement plants laboratory, commercial laboratory, educational institute, and we have supplied our product to SAARC country, African country, Gulf country as well. And our CRM have been quoted in IS 4031 Part 2, IS 1727, and IS 4031 Part 15. So the application of CRM is for the calibration of the instrument, validation, method validation, quality assurance of the data, establishing the traceability, monitoring of the performance, as well as the proficiency of the analyst. So this is the methodology for CRM's development. And for that, first we have to select the material, whether the material is proper or not. Then we have to verify the material as per the standard test. If it is laid down in the BIS standard, is some specific standard. Then after material verification, we have to do the material processing by blending, grinding. Then once the material is processed, we have to fill in the vials for any contamination, to avoid any contamination. Then we have to do the homogeneity test. So for homogeneity test, we have to do test of each samples, minimum 10 and maximum 30. After that, we have to go for the characterization and stability. In stability, there are two options. One is short-term stability and long-term stability. We have to follow according to the product specification. Then finally, we have to do the property value along with the uncertainty. Once the material is developed, we have to validate through our NMI of the India. And once the product is verified by the NMI of India, it's released as a BND, Bharati Nirdesak Dram, and followed by dispatch of the material. And in continuously basis, we have to check the stability of the product, because the stability depends product to product. Some products is having 5 years stability, some product is having 6 month stability, some product is having 2 years stability. So these are the basic equipments which are required in the cement and building material for physical and chemical test. Now coming to the Bharati Nirdesak Dravya. So basically Bharati Nirdesak Dravya is an Indian certified reference material, and the traceability of our NCCBM CRMs has been certified by NMI of India, CSIR, NPL. And we are very proud to say that the NCBM is the first organization in the country to get the BND marking in the area of cementitious material. And the first batch of NCCBM BND was released by our Honorable Minister, Dr. Harshvardhan, in the year 2018. Then in the year 2021, it was a very proud moment for us that our BND was dedicated to the nation by Honorable Prime Minister, Shri Narendra Modi ji, on 4 January 2021 in CSIR NPL. Then recently in the last, this year, 2 number of BND was released by Honorable Minister of Science and Technology, Dr. Jitendra Singh ji. So these are the details of BND which are available with us. Till date, we have developed total 18 numbers of BND. We have the product of OPC with different ranges. Lower range is up to 270 to 300 meter square per kg. Middle range is 330 to 370, and higher range is more than 400. Then we have the product of PPC, PSC, composite, WPC, fly ash. In the chemical category, we have the product of OPC, PPC, PSC, composite, fly ash, limestone, raw mill, clinker, coal, and GGBFS. In addition to that, we are in process for the development of other products like gypsum, bauxite, iron ore, petcoke. These are in pipeline. And our end users are all the cement plants, all the building construction testing laboratory, R&D organization, government organization, as well as educational institute. Now coming to the case study of development of PSC, how we have developed this CRM, particularly on chemical parameter. So this is the development process, and this process is defined in ISO standard, that is ISO 17034. So as being a ISO 17034 certified laboratory, we have to follow all the steps to develop the BND. And these are like verification of the materials, material processing, verification and calibration of equipment, acceptance criteria, then assigning the property value, defining the acceptance criteria for measuring levels and their uncertainty, and establishing the methodological traceability. So this is the check method for homogeneity test of the particular PSC product. So basically, random block method has been employed to ensure the product is homogeneous and or not. For that, we are taking here the 10 number of samples. And for each samples, we have taken 3 numbers of reading. And based on this statistical calculation, we can come to arrive that this particular product is homogeneous in nature. Then this is the methodology for ensuring the stability of the particular product. And for that, initially we check the short-term stability, followed by in sequence 1 year, in next 1 year, we will check the long-term stability of the particular product. Now coming to the characterization of this particular PSC, initially we do the initial screening of all the data, then statistical evaluations, followed by the uncertainty, that is type A, type B, and expanded uncertainty of the product. So these are the certified value of this particular PSC, and the parameters are LOI, SiO2, Fe2O3, Al2O3, lime, MgO, SO3, IR, Cl, sulfur, Na2O, K2O, and TiO2, P2O5. And these are the methods we have checked with 4032, then 12423, and NCB standard method. So this is the certificates. So this is the particular certificate of the PSC, and the important thing is that the validity of the certificates. So this is the distribution services, how we are packaging our samples and how we are dispatching these samples to our customers. Thank you, sir. Now, finally, this letter wrote by Bureau of Indian BIS to all the laboratory to use this BND in place of any certified reference for material from the overseas country. Now, the conclusion is that the replacement of important CRMs and saving of foreign exchange to boost the Make in India program and fulfill the mission and vision of our Honorable Prime Minister towards Atmanirbhar Bharat. Thank you.
Thank you, Mr. Shah.
And the next paper is Investigation of Vulnerability Using Microscopy with respect to the coarse and fine Romix residues by Mr. Venkateshwaralu, BC, Ashish Kumar, Ritam Chaudhary, and Sujit Ghosh by Dalmia Cements.
Good evening to all. I am from Venkatesh, New Product Development, Dalmia Cement Limited. So today is investigation of vulnerability using microscopy with respect to the coarse and fine Romix residue. Key points for the presentation: abstract, introduction, experimental work, sample collection, sample preparation for grinding and polishing, raw metal preparation, results and discussion, pyroprocessing conditions, and clinker phase transformation, clinker cooling conditions, quantification, it means point counting, conclusion. Here is clinker microscopy is a powerful tool for clinker and cement properties. Here generally we are using XRF and XRD in all our cement plants, but we cannot see the visualization representations of the clinker mineralogy. It means halite, belite, cellite, ferrite. Whereas we can identify the all phases by microscopy. We can identify the phase distribution, any clinker size, any clinker shape. By help of optical microscopy, we can rectify the problems, that is root cause analysis. So we can identify the both positive and negative aspects of are identified using the optical microscopy. It means we can define post-mortem analysis, whatever we are getting product, to determine the cause of that product. So the homogeneity of raw meal, reduction of burning conditions, and kiln conditions, cooling conditions, we can identify the optical microscopy. Mainly this paper, this current paper, chemical and mineralogical properties of raw meal, residue, and formation of clinker phases have been assessed for their role in cement strength. These results gives burning conditions, residence time in kiln, and slow cooling conditions, and raw material residue suggests inhomogeneous of heat distribution typical of pyroprocessing. Introduction. Mainly the quality control in clinker production process, they are using only XRF. By XRF, we can get all elemental analysis, then that data they are putting in Vogue equation, they will get potential phases, that is C3S, CTS, C3A, C4AF. Whereas XRD also we can identify in the mineralogy, but we cannot see the mineral structures. But by optical microscopy, we can identify the picture and phase of the distribution in the crystal structures and mineralogy, surface conditions of the clinker, and process conditions. Process conditions, it means what is the burner position, calciner, and flame length. That all we can identify. At the same time, we can identify the fuels also, what type of fuel they are using, and any changes in raw materials, that also we can identify the optical microscopy. In case studies, we are two timelines we have taken. One is April to May and June to July. We'll see that next year. Experimental work. Sample collection. Sample collection, we can collect spot sample, we can do compound sample also. But here we can collected samples from DPC, deep pan conveyor, and as a representative samples, 15 to 20 kg, then we make as a, that is a representative sample for the microscopy analysis. Specimen preparation. After the preparation of representative samples, we take that sample for that specimen by using resin and hardener, and we make the specimen. After specimen, we can grind it the different silicon carbide papers. Then after that, we can polish the alumina paste and then go for the etching, HF etching. Here we can identify the all phases at a time, one etching. Easy to identify the all phases, halite, belite, cellite, and ferrite, free lime, periclase. So raw meal preparation. In the case study, raw mix was prepared as per our DCBL standard design. Raw meal samples were analyzed, XRF and XRD, but analysis showed very similar, except the residue. Here, clinker sample has bound high residue raw meal samples contained high amount of belite clusters and high amount of free lime clusters, whereas fine residue, we can not find the belite clusters and free lime clusters. This is the raw meal preparation chemistry: silica, alumina, iron, CaO, MgO. In timeline, April to May, June to July. April to May is high residue, June to July is finer. So there is no differentiation in this chemistry except only residue. Here only residue is 90 micron, April to May, 90 micron, 22 to 22. Here is 18 to 18. Here we can identify the homogeneity, inhomogeneity. We can identify the where is coarser raw meal, and we can easy to define the distribution of the crystals. Results and discussion. Pyroprocessing conditions. Fineness influences the burning zone temperature, which turn control clinker phase formation, crystal size, diffusion distance, incomplete phase transformation. This is the direct effect on the soundness of the cement. During the major shutdown, we are adjust critical work such as burner position, determination, flame length adjustment, and small modifications has been done. So after the shutdown, we analyze the samples, the crystal sizes, small crystal sizes we can identify. That is the high reactivity clinker. It is a direct impact on the strength also. This is the freeing clusters, low diffusion distance. It means insufficient burning zone temperature or long length flame. Whereas moderate to low diffusion distance, it means sufficient burning zone and short length flame temperature. Clinker phase transformation. Here 1250 degrees Celsius tricalcium silicate decompose into coarser matrix. It result burning to under red aging conditions. Under red aging conditions means allied converting to ferrous inclusions. Ferrous inclusions means what we are giving the substances. It means 12 CaO plus 2 SiO2 plus 2 Al2O3 plus iron. It convert to product, that means in the presence of chemical reaction, it convert to C3S, C2S, C3A, C4F. Whereas the absence of oxygen, it means deficiency of oxygen, it is not completing to converting to the alate form. Belate is not completing converting to the alate. It means it is also reactive, but whenever it is reacting with water, that CSH gel is forming, calcium silicohydrate, that is not stable. So due to that, we are not able to get one-day strength. Here cooling conditions is a major role in the clinker. Here cooling conditions is, we can identify the cooling improve the quality of the cement. Slow cooling and fast cooling. Slow cooling enhancing the magnesia crystals, it means periclase crystals, and it is enhancing the ragged bellates and fingered bellates, at the same time increasing the alate. It is demerit of the clinker. So whereas fast cooling, we cannot find the bellate clinkers, ragged bellate clusters, and we can find it small crystals, and it is in fast cooling, we cannot get that crystals form of the magnesia. We can get only that glassy phase magnesia. It means highly reactive. So it is, fast cooling is better than the slow cooling. This is the ragged cooling, slow cooling, April to May, fingered bellates, slow cooling, June to July, well-rounded bellate, it is moderate cooling. Whereas rapid cooling conditions, we can get smaller alate and bellate crystals. It exhibits the faster strength growth. This is a small comparisons of the microstructure clinkers. Phase distribution, April to May is very poor, and June to July, well homogeneity. Alate, deformed alate, whereas in June, July, ideal and hexagonal. Bellate is ragged form in the month of April to May. In the month of June to July, ideal and rounded. Matrix coarser, finer. Diffusion distance lower, moderate. Flame clusters more and low. Bellate clusters high, low. Reducing conditions high, low. Here, reducing conditions, one more test is there. We can identify the even process conditions every hourly also. That is the mega test. Solution A, 2,2 bipyridine, and solution B, trisodium citrate. Then that we can identify the whether it is processing conditions, whether reducing conditions, yeah, oxidation conditions. We can easy to identify the unskilled person also in process. Here some measurements, microscopy, crystal measurements, alite and belite. Here maximum alite size is 58.2, average is 19.6. That average 10 to 20 micron is 60 above percentage, 19 to 60.
How many more slides you have?
Yes, sir.
How many more slides you have for conclusion? Because time is already over.
Please conclude.
And belite crystals, here belite clusters 122 reduced and free line clusters decreased. Here point counting, here microscopy, actually realistic picture we can identify in the whatever we are analyzing the clinker. Here we have taken 300 points were counted at high magnification. Here XOD supporting to microscopy for the quantification, whereas we counting the microscopy and XRD more or less same, whereas compared to the Bog equation, it is not matching, but microscopy and XRD similar to same. Here is 50, 55.98, 58.03, more or less same this. Strength. C3S plus C2S is 76.85 in month of April. That time 28-day strength is 50.18. May month 75.82. Total silicates, it means C3S and C2S. Strength is 50.52. In month of June 80.1. Strength is 28-day 60.12. In July C3S plus C2S 80.94. Strength is 59.07. Whereas free lime also in 1 day strength 2.15, 26.18 in month of April, May month 25.78, with respect 3.19. Gradually strength is increased.
Can you please close
Conclusion.
the presentation?
Okay, sir. This residue of raw meal impact the clinker phase formation, can identify the optical microscopy. Specific properties of cement raw materials are critical to plant efficiency, energy consumption based on the investigation of burnability using by microscopy with respect to the coarse and fine raw mix residue. Microscopy identify the critical areas where changes could be made to improve burnability, pyroprocessing, cooling efficiency, lower fuel consumption. Raw meal residue on 90 micron sieve, initially more than 22%, which is now reduced to 17 to 18. That will improve the clinker quality.
Thank you very much.
Thank you.
So, if the second presentation, impact of CSR initiative on water, footprints of cement plant, is it ready, Mr. Raju? Okay, please.
Just try it. Just try it, whether it is, try that presentation and whether it is working.
Once again, good evening, dignitaries on dais and all industry delegates. So, this is Ramaraju, Dalmia Cements Limited. So, I am here to present water conservation, impact of water conservation which has been implemented at our plant. It is in Kadapa district of Andhra Pradesh. We have 2.5 MMT integrated cement plant. So this project was done under our CSR scope. In CSR scope, under our CSR, we have water, climate action water, climate action energy, livelihoods and social development are these four thrust. We have four thrust areas. Out of four, we have water conservation is more focused thrust area. Why? Because our industry consumes water. So to restore that under CSR, we are doing the water conservation project. it benefits both community as well as our plant water consumption needs, and so this is our geographical area. In the second slide, our plant is in Mailavaram Mandal of Kadapa district. So we are working in 3 mandals of adjacent to our cement plant. This is one of the most drought-prone region of in India. So in India, most drought-prone district is Anantapur, which is second drought-prone district in India is Anantapur, which is adjacent to our plant, our district. So the entire our plant also comes under a drought-prone area. So here our average rainfall is 709 millimeters. And our forest area is total 32.57 out of 5,961 hectares. And the groundwater availability in the Archean crystallite rocks consists mostly granite genesis, magmites, and generally it's a lacking primary porosity. And pre-intervention situation. So before we take up our water conservation program, the situation was the soil erosion was very high due to rainwater runoff. And there was no adequate structures to hold the rainwater. And due to this, groundwater depletion is more every year, year by year. Because of this, existing water bodies also could not yield, good amount of water. So it's ultimately irrigation sector and other sectors are being affected. And it leads low agricultural productivity per unit of land, and the severe water scarcity for drinking, irrigation, and industrial purpose also. During especially summer season. So by observing this, in view of this, we conducted a detailed field survey in 13 plant surrounding villages. So we prepared a detailed project report and net plan for water and soil conservation project. So in that, so we prepare in our DPR, drainage line treatment, area treatment, agri productivity enhancement, and livelihood promotion are the main components. Drainage line treatment, mainly we constructed the structures on existing streams and channels, water streams and channels. Area treatment is to control to prevent the soil erosion. We constructed many structures on land. And agri-productivity enhancement and livelihoods, these are the, as a result of drainage line treatment and area line treatment, agriculture productivity will enhance, and as well as livelihood promotion will also take place. So we aim to cover 3,638 hectares of land and 8,500 beneficiaries across 13 villages, plant surrounding villages. And regarding project implementation and monitoring, so we carried out through participatory governance system. In the participatory governance system, representatives from our organization as well as our community, as well as representatives from the community are there. So there is a committee formed to for the implementation as well as the monitoring of the project. And under this water conservation project, if we talk about details of structures we constructed, is borewell recharge structures we did 40, diversion drain we did 8,154 cubic meters, and the field bund with stone revetment we constructed 5,148 running meters, flood control bund 305 running meters, farm ponds It measures 10 into 10 into 2, 125. New field bund, we able to complete 7,565.79 cubic meters. And pebble bund, we did 4,734 running meters. Stone check for 3,586 running meters. Stone outlet 83 numbers we have done. And the trench cum bund 833 running meters. Water absorption trench 8,045 running meters. And channel 600 cubic meters we have done under area treatment. The area treatment, these all structures have constructed on the land, agricultural land as well as barren land, to control the soil erosion due to rainwater runoff. And the drainage line treatment, these mainly we did on existing streams and natural channels. That is, we constructed 12 number of check dams and 4 percolation tanks and 12 sunken ponds under drainage line treatment. Yeah, these are the snapshots of the structures. This first one is the borewell recharge structure. This borewell, generally during the rainwater, during the rain season, rainwater will run off. So there was no structure to hold the rainwater, to percolate the rainwater. So this is the structures to collect, to hold, and to percolate rainwater into the ground. And the farm pond is 10 into 10 into 2. It has 2 purposes. Generally, farm pond, it can be utilized for the critical irrigation during the summer, and simultaneously we can recharge the groundwater also. The check dam we constructed on the drainage line. That is one of the existing streams near our cement manufacturing unit. This is a mini percolation tank and water absorption trench. So these are, to hold the water and to recharge the water, the purpose of these 2 structures. And the drip irrigation system, this is under, generally the practice is in our farmers earlier, they were doing the, in traditional irrigation system, they are irrigating. So we introduced the drip irrigation system, so that 80% of water consumption for the irrigation has been saved. These are the, again, different structures under water conservation project. And if we talk about the outcomes of the project, we treated 3,338 hectares of land and constructed 304 structures. 8,289 farmers have benefited, and mainly water positivity. Now our plant has, attained 16 times water positive. Out of 16 times, our CSR initiatives contribution is 8.42. Remaining is in our plant, mined out pits, it was filled with the rainwater. So, total, as a result of these structures, we could harvest 25.41 lakh cubic meters. So, the formula is our annual freshwater consumption is 3,10,470. So, out of that, we conserved the water 25.41 lakh cubic meters. So, because of this, 7,500 small and marginal farmers have got protective irrigation, and 450 acres land brought into micro irrigation. And this is the year-wise water conservation scenario. So, impact. So total 80% of water bodies able to store the water across the year. and 9% farmers were able to do agriculture in barren lands. Water level has been increased 10 to 15 feet in 90%, 94% of open wells and bores. So 23% of farmers have used village ponds and to get benefit of it. Thank you.
Thank you, Mr. Raju.
So now I will request Shri Prakash ji to summarize this session.
Thank you one and all for the nice presentation. First of all, very sorry for the inconvenience that we could not take the paper at right time because of some technical issues. However, we have almost on time. Yes. So that impact on the CSR initiative by Mr. Ramaraju was a very good effort and is a requirement of that time also. In the third paper, the reducing the carbon footprint in cement industry, energy saving initiatives by Ms. Asha, arresting air leakage, compressed air leakage audit, utilization was only 60% as mentioned by her. That is again a very important thing because energy saving is energy generation. On the fourth paper, the uses of bamboo as AFR to reduce CO2 emissions by Amitabh Rai. It's a really good initiative and it's I think it's a requirement again, and it's an untouched field for the North India because we don't have bamboo here. Again, we have not mentioned something about the quality parameters of the bamboo in that paper, but again it is very much required. Significance of the intermediate checks by P. Shrikant of the NCB team for the laboratory equipments and the frequency required to ensure the good health of the equipment by doing the calibration from the primary and secondary standard. Again, a good initiative and we should follow it in our plants also. The patented innovative anti-stick work by Mr. Jigar Shah, Ankle's Adhesive Technologies. Downtime in the cement plants equipment can be reduced, and the benefits of epoxy silicon-based hybrid technology that can be used and other technology can be used by elaborated very well there. And next paper in the development of CRM, targeted quality product and excellence in the competency by Mr. S.K. Shah from the NCB team again. That is, again, we all are dependent from the cement sector. We all are dependent on the NCB, and we request NCB to broaden their horizon and thus in this aspect also. And in the last investigation of the vulnerability using microscopy with respect to coarse and fine raw mix residue, that I was expecting something regarding the vulnerability test, but this is the plant case study. Again, it's a very good study, and microscope is always useful along with XRD and XRF. So I think this is all about. All the papers were very well presented, and we are lucky that we are on time until now. Thank you. Sir.
As Mr. Jayaprakash has summarized all these things, the most important part is we are in business, and in the center we see the coin. So all these efforts which are being made or the papers which are being presented here, somehow all these things are related with profit. Whether it is leakage from compressed air or anti-stick coating and to avoid the stoppages, all these things are somewhere related with profit, because whenever we have a stoppage or breakdown in the plant, we have to start the plant again and we have to consume more coal, more power, and that is loss. So we all should explore all these new technologies. Similarly, in case of bamboos as AFR, this is a new thing, and in Northeast it is abundantly available, but in North India also, at many places people are trying how we can cultivate this particular thing, and that may be a win-win situation for company as well as villagers, because in that case we can motivate our villagers to do this type of agriculture in their fields, they can also earn and company can also get the profit out of it. Another vulnerability test was a good paper, but at the same time, we would have to see, because fineness, increasing the fineness in raw mill will again cost. Definitely, vulnerability will improve, and it can impact on the heat consumption, and by that way we can save money, but at the same time we would have to see how much power will increase in raw mills. So that thing also should be covered in that paper. The excellent paper, I will congratulate Mr. Ramaraju. It was a Bhagirathi Prayas by your company, and it's a need of the hour because most of the cement companies are sitting in the area where water scarcity is there. So, hats off to you, and really a good efforts done by Mrs. Dalmia. All the papers were very nice. Thanks a lot for presenting these research and papers and ideas here with NCCBM seminar, so that all the delegates and all the companies can get benefited out of it. Thank you.
Thank you, sir. I would now request Shri Amit Trivedi to kindly present mementos to our Honorable Chairman and Co-Chairman.
If there is any question, we can, yes.
Yeah, good afternoon to all. This question is actually for Mr. Jigar Shah for Henkel adhesives regarding the anti-stick coating what he has presented. The presentation was excellent, and the kind of work what you have done also is very good with respect to the industry challenges what they are facing in the plant, especially the jamming of chutes, silos. And also this is one of the problems in what we have seen across industry. Some of the industries are facing in with respect to the unloading of the wagons where they don't have wagon unloaders. So just my question is one that with respect to this bulk solids flowability, we normally measure flowability with respect to flow coefficient, and particularly powder handling or material handling, when you consider there is a case of wall friction angle which is measured better, and with respect to that angle normally we consider how better is the flowability of the material and with, when it is in contact with the any liner material. So have you tested any that sort of wall friction angle with the your this anti-stick coating? Because what I feel is that the contact angle what
Sir,
you have
please
measured.
keep the question little bit short, sir.
Yeah, yeah. So
Please.
just wanted to know whether you have to say tested the wall friction angle with respect to your anti-stick coating.
So wall friction angle is not tested. Our coating, when you apply on the surface, okay, so it will actually create the angle which is the material is coming onto that particular surface, okay. So that angle, if it is higher, then there is always we can find the kind of higher anti-stick kind of property.
Yeah, so that is what my point is, that better to say reliability factor is with respect to wall friction angle only. So instead of contact angle, to say it will be a better to have a relation with wall friction angle in that case.
Sure, we can explore that, sir. Thank you.
Thank you.
So, thank you.
My question to Mr. Shaw, NCCBM, regarding the CRM or BND, actually there is some query about the validity. Actually, the calibration some certificates, hydrated lime or like this, only the 1 year validity, and company received almost 6 month validity is already go down. So then the most of now lab is going for the NABL. So then always the question mark for this is validity. Calibration certificate. So then we have to increase the some validity for hydrated lime or like this type of materials. And second thing is the normally PPC and the standard sample is a 400 blend or like this type of. But nowadays on market average blend is near about 330, 350 like this, yeah, 320 like this. But NCBM fineness for calibration, the BND or a CRM is always the higher side fineness. So then this is the also as normal market average sample also, if it is possible.
No, so regarding this fineness, actually already we have mentioned that we have different range of fineness in OPC. So we have range of 270 to 300, then 330 to 370, and 400 to 420.
But PPC?
In PPC, we have range of 350.
Now present is, I think, for near about 390, 380, I think.
No.
And for hydrated lime or like this type of certificate also?
No, for hydrated lime, the validity is absolutely 1 year. And we have checked the stability of this particular product. We have found that after 1 year, the stability is not confirmed. So
but
we cannot
no other suppliers already is mentioned that the foreign suppliers,
you can
they have provide also for 3 years hydrated lime.
Yes, you can discuss this particular thing in separate also, because time is already.
Yes. Thank you.
Okay. So it is over 7 minutes.
Right.
So next,
thank you.
Let us close this session. Thank
sir,
you.
we are again fortunate enough to have Dr. V.N. Mahapatra sir for the special session on the total quality management. He is an institution in itself. So we request Dr. Saab to please be on the stage to have this deliberation. And we would like to sit there at this place. Yeah, please, sir. Yeah. We request Raju Saab to be here, sir, on the stage.
So I would request Shri Amit Trivedi to kindly present mementos to our Honorable Chairman and Co-Chairman. We extend our sincere thanks to Shri Vinay Saxena, Shri Prakash Vrati, and Shri Amit Trivedi for their esteemed presence. So ladies and gentlemen, that concludes this session. Please be seated as we are moving on to the